Okay, so let's turn to the second page of this lesson and let's just finish it off. The square root of 20n times the square root of 8n. Okay. I could go ahead and combine if you really want. You could just simplify the square root of 20. There's so many things. I think we should just stay focused here. Let's just go ahead and combine them, right? Square root of 160n squared. So the question is, what is the square root of 160? Now, I don't have my perfect squares on this page, but eventually I also hope that you start to memorize the perfect squares, right? And you don't really need them on the side. It starts to become obvious. This is just the square root of 16 times the square root of 10. I know that the square root of 16 is the best choice. I could have used the square root of 4, but I don't want to do that because it would have you have to simplify even further, right? Using the largest perfect square factor is always the better idea. This becomes 4 root 10. And we know that the square root of n squared is simply just n. So our final answer is 4n root 10. Ooh, here there's no way that you would want to multiply 275 with 44. So here's a tip. Always simplify first if possible. This allows you to avoid trying to simplify very, very large numbers. So obviously 3 is on the side. Let's go ahead and simplify 275 first. You want to use a perfect square that's a factor. And for me, whenever I see something that ends in a 5, I automatically think of 5. And I automatically think of square root of 25. Now, I'm not sure if there's a better answer to use than square root of 25, and I'm calculating. The answer is no, there is no better choice because this is square root of 11. If that number was also something that could be simplified, then it just tells me that square root of 25 was not the best choice. But I do know that just confirming that, yes, this is the best choice. And actually, I think this might be the only choice. So this becomes square root of 25 is 5, and 5 root 11 is going to be square root of 275. Okay, let's also simplify the square root of 44, and that's decently obvious. It's square root of 4 times square root of 11, and the square root of 4 is 2, and this becomes 2 root 11. And what's funny is, oh, I'm starting to see why. Because we now have 5 root 11 times 2 root 11. The 5 and the 2 obviously become 10. The root 11 with another root 11, they finally found each other. That becomes a whole number of 11. Now also, class, let's not forget about the 3 that was just on the side the entire time. So this ends up being 33 times 10, which ends up being a final product of 330. Wow. I did not expect that answer, but that seems everything we did was right, so that seems good. Okay. And then 13, I kind of made a video about this earlier, but if you have the square root of a decimal, you always want to convert it to a fraction to make your life easier. This becomes 18 over 100. And then, wow, so this becomes the square root of 18 divided by the square root of 100. Square root of 18 is simply 3 root 2. Square root of 100 is 10. And this is 3 root 2 over 10 times a 5 at the end ends up being, wow, this ends up being 5 times 3 root 2, which is 15 root 2 over 10. But then the last step is you have to simplify that. 15 over 10 is not the final answer. It's just 3 root 2 over 2. These are really, really well-written questions, 11, 12, and 13. Tricky at times, but just have to be comfortable. Okay, our last topic of the lesson is a very, very important topic. I kind of talked about it in the previous lesson, but there's this concept of rationalizing the denominator. We must realize that in math, we are never allowed to leave the denominator as a radical, as a root. You must not keep the denominator as an irrational number, basically, right? Conceptually, if you think about it, the denominator is the amount, the total amount. So if you told me that you had a total amount that was non-terminating, that just doesn't sound possible, right? Like let's think about it in terms of probability. 1 out of 4 is written as 1/4, right? If you told me that the denominator was this number that did not stop and did not have a pattern, aka irrational, that just should not happen for the denominator when the denominator should be the whole, right? So the one thing we need to do is pretty simple. If I have the 1 divided by square root of 5, all we have to do is multiply the top numerator and the denominator by the same thing. We're going to just multiply by the square root of 5. We know that square root of 5 times the square root of 5 gives me a whole number of 5. We also know that the square root of 5 divided by the square root of 5 is actually a value of 1. In other words, this does not change my initial value. All it does is it represents it in another way. Okay, we know that this is the multiplicative identity property, where you can multiply anything by a value of 1 and it will still maintain the identity of the number, right? Final answer here is the square root of 5 divided by 5. Now this looks a lot different than what it used to, but it's because we rationalized the denominator. Okay, I already know some questions. Mr. Kuo, does that mean you just always multiply both the top and the bottom by the denominator? In many cases, the answer for that will be yes. Okay, if I just take number 15, for example, and I do 4 divided by root 2, I can multiply the top by root 2, the bottom by root 2. You realize that this is just a value of 1. I haven't really changed the value of this if I multiply, but then I know that the top is going to be 4 root 2, the bottom is just 2. Just like in this previous example, you are not allowed to leave it like this because these whole numbers can be simplified. These whole numbers simplify to 2. So then you get 2 root 2 as your final. Okay, I'm going to go a little bit faster now. 6a divided by square root of 3a. You just multiply both the top and the bottom by square root of 3a. Okay, again, value of 1 does not change. So then you get 6a root 3a over 3a, right? Square root of 3a times the square root of 3a obviously will jump out and become regular 3a. Now, I hope it's starting to be pretty obvious that you still have to simplify these whole numbers, these not necessarily whole numbers, I'm sorry, but the numbers that are not in the radical. They can always be simplified. You must always simplify them if possible, right? Just like it's just like that. 6a over 3a, you would never write that as a final answer. You divide the a's and you divide the 6 and the 3 and you get 2. Two root 3a is the final. Okay, 4 more questions. We can do this. Again, if at any point you want to pause the video, go ahead and feel free. 15 divided by a square root of 5. I'm going to multiply both the top and the bottom by a square root of 5. And you get 15 root 5 over 5, which simplifies. You can see that this is kind of like what we want you to be seeing, right? This is kind of expected at this point. This is 3 root 5. 2 over root 300. I'm going to actually do something quite fun, and I'm going to simplify root 300 first. That becomes root 100 times root 3. This becomes 10. So essentially the question is 2 over 10 root 3. okay? Still not an acceptable final answer because you have a radical on the bottom and you must always rationalize the denominator. The denominator is never allowed to have a square root. So I'm just going to multiply by the square root, right? This goes into the opposite of what you asked, Mr. Cole. Do I just always multiply the denominator by itself? Well, not in this case. I really just have to multiply the top and the bottom by the radical, not the 10. I don't need to multiply it by 10. I just need to multiply by the radical. Okay, this becomes 2 root 3 over 10 times root 3 and root 3, which actually becomes 3. So this is 30. And then you can simplify this one more time. This is root 3 over 15. Very good question. Point 8 with the line on top, number 18, is simply 8/9. So we know that the square root of 8/9 is equal to or equivalent to the square root of 8 over the square root of 9. And we know that that's just 2 root 2 over 3. Then finally, if we're allowed to multiply numerators and divide by the numerator by the denominator, we're also allowed to cross simplify, right? So this, oh, actually I do not see a cross simplify opportunity. My bad. Square root of 3/4 times square root of 7/8, that's just going to become square root of 21 over square root of 32. Square root of 21 is simplified. Square root of 7 times square root of 3. There's nothing you can do with that. Square root of 32 is simply just square root of 4 times square root of 8. And I realize all I've done is literally just jumble these numbers again, which is kind of silly, right? So this becomes square root of 21 over 2. Wait a minute. I should have used 16 for this, right? This should have been 16 and 2. So it's okay. I'll just write it as 2 times 2 root 2 because square root of 8 is 2 root 2. Okay, so then this becomes the square root of 21 over 4 root 2. And we still need to rationalize the denominator. So I multiply the root 2 by root 2. And I get the square root of 42 divided by 4 times root 2, which becomes simply 8. The reason why I'm thinking about it so hard is because I'm trying to determine, is the square root of 42 exactly simplified? And I'm double checking. Yes, it is. That is the final answer. Okay. Hopefully you enjoyed this lesson. It's really, really an important lesson. You'll use these concepts a lot in high school. You need to be comfortable square rooting things, squaring things. We do this a lot in Algebra 2. We do this a lot in solving for missing sides of the missing side of a triangle. So you just have to use your squares and your square roots. You have to master the concept, and this is a really important topic. Okay. Please let me know if you have any questions, and I'll see you later.